Today's lesson is on the environmental impact of ships. And as we know, ships in general carry a lot of chemicals and a lot of different things that are harmful to the environment. So really what we're talking about when we're talking about the environmental impact of ships is how we can mitigate or keep a lot of these things out of our environment, or at least lessen their impact. So you look at this opening slide, and you can see in the top left we have the motor vessel Torrey Canyon. Now this was a spill that happened in the UK. We'll talk a little bit about this a little bit later. We also have in the top right something that happened a lot closer to home. This was the Exxon Valdez, which was in Alaska in 1989. And then again, another one that was close to home. The middle photograph here is of the Deepwater Horizon. So this one right here in particular was huge for us in recent times. And then you can see down at the bottom right we have some low sulfur fuel. So this is fuel with less sulfur than normal in it, and we'll again address that later on. As well as some people down here taking water samples to make sure that the water quality is what it's supposed to be. Some of the overall objectives of this lesson are to make sure that we understand that pollution prevention is an internationally governed thing as well as domestically governed. So a lot of our domestic law is driven by international policy. Now, although there's no direct relation to international regulations and domestic regulations, we do reference many of the domestic laws that we have here in the United States. We reference the international standards quite often, and we'll see that as we go on here. The big ones, of course, pollution regulations in general, ballast water management, which you may not typically think of as pollution, but I'll explain later, an emissions control area, and that's basically for air pollution, and something called a vessel general permit, which encompasses most of these things, but is a good gauge on if a vessel is in compliance. And then finally, we have even more strict guidelines, or in some cases less strict, that is given to us by the commandant under the pollution prevention for military vessels, and this is called the Vessel Environmental Manual, and this is the commandant instruction that's listed down here at the bottom. So, looking back, trying to think, hey, why are we even talking about pollution prevention? Well, so they've been talking about it for a long time. In 1954, the United Kingdom identified oil pollution as a problem. Now, they weren't talking about big oil tanker spills. They weren't talking about big releases due to underwater drilling. However, they were concerned about the amount of oil that was going back into our ecosystems that were close to land. So in 1954, they actually adopted what was called oil pull at the time, which was prevention of pollution of the sea by oil, or shortened to oil pull or oil pollution. Later on, the IMO, the International Marine Organization, took control and actually developed this further into several annexes, which we'll discuss later in the lecture. But in 1967, the Torrey Canyon, which is the vessel that was on the top left of our slide earlier, ran aground, entering the English Channel, and spilled 120,000 tons of crude oil. Not gallons, tons. So this spill was an amazingly large spill, and at the time it was the largest one. And it has since been beaten by others. However, there wasn't robust regulation in place, and there was no good response method for this event. So what they ended up doing is the Royal Air Force dropped a bunch of 1,000-pound bombs on the vessel, added some aviation fuel to it, and tried to burn it all off. Of course, what they did is created one type of pollution for another, equally as harmful, maybe arguably more so for humans. But anyways, their idea was getting rid of the oil, and they decided to burn it off. Probably not the best choice. So we look now, and we have something called MARPOL, which is marine pollution, right? So this is a postcursor to oil pull, and it incorporates more things. And you can see it was most recently consolidated in 2011 in a rather robust plan for pollution at sea. Of course, I talked about the annexes, and they are extremely important. This is one of the big things I want you to take away from this lecture, is that these annexes are important, and understanding what's in them is important. So you can see them listed here. Annex 1 is oil. Annex 2 is NLS, or noxious liquid substances in bulk. Then we have harmful substances carried by sea in packaged form. We have sewage, garbage, and air. And note each one of the annex numbers that are by them because that's important information to understand. So as we look at these annexes a little more in depth, let's talk about oil. Of course, it's number one. It's number one on the list because oil pole turned into MARPOL, so it made sense. This was the driving reason for this type of prevention step to begin with. So it provides limits to how much oil and pollution people can put into the sea. And what this does is allow us to regulate not only just what we put into the ocean, but how we transport this cargo across the seas and what types of structural things need to be put into place in order to move certain types of cargo that fit into this oil pollution kind of guideline. And there's some other things that we're going to talk about, including the oily water separator, which is a piece of equipment on a ship that's used to remove oil from water. Typically we'll have a lot of oil in our bilges, and we'll also have some water in our bilges, and we can't let it stay there. So we need a way to remove the water, discharge it overboard, and hold on to the oil. An oily water separator does that for us, and that's also governed by Annex 1. We have Annex 2, which is our noxious liquid substances, or NLS, and these are things that are in bulk form. So we talked a lot about different types of vessels at the beginning of this course to include bulk carriers for iron ore, bauxite, coal. There's a plethora of things that can be carried in bulk. So this one pertains specifically to bulk chemicals that are being transported across the seas. And it's important that each of these vessels is actually permitted for this type of cargo. Annex 2 covers all the requirements for those type of items and goes into great detail as to how we should actually avoid spills both through process and through mechanical means. So Annex 3 is harmful substances that are carried by sea in packaged form. And you might notice some of these placards off to the right. You may have seen them before on over-the-highway vessels. These are very common. The point of these is to quickly assess what type of toxin could be inside these containers so that emergency responders and cargo carriers, both on land and sea, can quickly assess the damage or assess the hazards that could be there and plan appropriately. You can see how this would be important for a cargo ship to understand what kind of cargo they were holding, specifically when they don't inspect every single container that goes on board their ship. Being able to quickly glance at a placard will allow them to see immediately what types of dangerous goods are there. And we use an IMDG, an International Maritime Dangerous Good Code, in order to identify them. Our next annex is sewage. Now, sewage is kind of one of those things you can't avoid. If you put people on ship, you're going to have sewage. One of the big things here is currently the United States has its own standards that requires you to be 3 nautical miles offshore in order to dump waste that's been ground and commutated. So that means basically pureed. And we use this rule and require others to use it as well when they go to another foreign country. So what does that mean? That means if I pull into Dominican Republic and they say I can discharge sewage at the pier, I have to follow the more restrictive guideline because I'm a U.S. vessel, and I have to move 3 nautical miles offshore before I do so. I also have to make sure that if I'm discharging any type of sewage to a truck, that the reception facility meets the requirements of Annex 4. So this is all important things. In your equipment and control of discharges, this is basically what's going to flush our tanks out into the ocean, and we need to have good positive control on that and have systems in place. So sewage is important. We don't want to dump sewage also in sensitive marine areas, not only just 3 nautical miles within shore, but also if we have a sensitive marine area like a reef or any type of area that we deem as sensitive on, and you can get that information off a chart. Of course, garbage. Garbage is kind of a big up-and-coming issue. Until recently, we used to just dump anything we wanted to into the ocean. It's having detrimental effects on fish counts, on the ecosystems that exist within the oceans. More specifically, there's a very visual indicator of how damaging this is in the middle of each of our oceans, the Atlantic and the Pacific. Now, the Atlantic and the Pacific have currents that go around the perimeter, and while they're circulating, they're actually pushing and pooling all the water to the middle, and that's called your mid-ocean gyre. When you do that, you take all of the surface substances, so anything that's floating like styrofoam, plastics, wood, dunnage, and you're piling it all into the middle. So we've basically created giant trash islands And it's having a really detrimental effect not only to avian species, but to aquatic species as well that are getting tangled into this garbage, or actually using it as a new ecosystem, which is nowhere near as healthy. So there are plans in place to go nationwide a no discharge rule, which would mean we couldn't throw anything overboard. Now, there are some concessions to this within the United States Coast Guard that says if we have an emergency or there's some sort of mission that we need to accomplish and the garbage on deck is inhibiting our ability to do so, we can put it overboard, but it has to be documented. It's all about documentation, and that's what this garbage record book is, as well as garbage management plans. So we can go back into the Vessel Environmental Manual, and we can see specifically what our garbage management plan must look like, to include logs and placards that have to go all over the place. So we also have, you may not initially think so, but our food waste can be considered garbage as well. Now we typically separate this out, and we can put our food through a macerator, which basically turns it into the same consistency as the sewage that we're putting overboard. And again, we'd have the same requirements. Food can be discharged no closer than 3 nautical miles if it goes through that type of process. If it's not, and we just have a slop bucket with whole food, whole oranges, maybe a whole chicken, a watermelon, that has to be done more than 12 nautical miles out, and ideally it would be ground and commutated as well, although not required at the time. But again, that's something that needs to be logged every time we throw it overboard, what we're throwing overboard, and exactly where we are at the time. And some of the sea states and whatnot are also included in those requirements. So now we have air. Now air in the early 2000s became a really big deal in the maritime industry because the EPA did a research project to try and determine where all of these respiratory illnesses were coming from on these coastal port cities. And they found that most of these port cities were actually being affected by the emissions from these large vessels coming into port. Because unlike your typical vehicle, which has an exhaust that comes out, and then it goes through what's called a catalytic converter, and then puffs out some water, some carbon dioxide, a couple of other chemicals that come out from the combustion process, relatively harmless in comparison to the diesel engines that are being brought in close to shore. So what this is saying is we need to figure out a way to decrease these emissions overall. Not only do we need to decrease these emissions, but we need to find a way to clean our exhaust stream in general. So sulfur, SOx, sulfur oxides, that could be SO2, SO3, any sulfur oxide would be considered a SOx gas. So how do we get rid of SOx? Well, sulfur is predominantly found in our fuels. So if we can produce low sulfur fuels, we will inherently then decrease the amount of sulfur we're putting into the environment. Okay, so another other big thing that a big diesel engine produces is nitrogen oxides. So because of the combustion process, again, there's tons of nitrogen in the fuel. And the way we pacify that is not all that different from how we would do it in a vehicle, although more involved. So we do something called selective catalytic reduction. And what this does is it actually injects a urea stream into the exhaust. Yes, urea sounds a lot like urine because chemically speaking it's not all that much different. And that's how we can actually filter out some of our NOx emissions, as well as tuning our engines so that we are outside of certain temperature ranges when combustion happens. So combustion at certain temperatures can actually increase or decrease the amount of nitrogen oxides that we're producing. But no matter what, we still have to figure out a way to pacify these items. The air annex also includes volatile organic compounds, which are typically found in paints and other substances of that nature. Shipboard incinerators, so if we're burning a bunch of garbage, well, we're doing what they did with the Torrey Cannon, right? We're taking one type of pollution and changing it to another. So air pollution in general is covered under Annex 6. So some items that aren't specifically covered in the annexes are basically these other pollution items here. Pollutions from invasive aquatic species. Now I told you at the beginning, ballast water management, like how is that a pollution? Well, this is how it becomes a pollution issue. As our ships travel, they pick up water from one port in their ballast tanks in order to keep them stable. And as they move to another port, they can transport other organisms with them. We can see here a picture of a zebra mussel. This is a highly invasive species, especially when put into an environment where it has no known predators, which is what these red dots are down here in the bottom left, is the proliferation of the zebra mussel. You can see some of the reasons why this is bad for the marine life, because it can basically choke out existing life, take all the resources, And again, you can see here, this is a pipe that's been completely inundated by zebra mussels, so it increases our overall maintenance costs for our vessels. So it's a good thing for us to try and figure out. There's also another species called the Asian carp, which is currently making its way up the Mississippi and is threatening to make its way into the Great Lakes, which is another item here that's just uncontrollable for us because we don't have any known predators for the Asian carp. And it's a very robust species that actually can live outside of water for periods of time. So not exactly in our best interest to move those around in our heartland waterways. So you can see we've been working on this for a while. Zebra mussels were something that we've been talking about since 1988 and even before. They finally created a working group and started passing prevention to control this. Some of the outcomes are with this ballast water management is now ships have to go 200 nautical miles offshore to actually flush their tanks 2 or 3 times before bringing it back in, and they can't discharge their ballast tanks anywhere within that 200 nautical miles. You may know the 200 nautical mile mark because that's our exclusive economic zone, and that's basically to the limit of where we can assess any type of legal rights. So this is what we're saying. Don't bring in your ballast water unless you have some sort of pollution prevention or mitigation device installed. So as we move through, we're looking at all these different laws, and I told you that they're driven domestically, but we've been talking about international law. So the way we figure out how these all play in is 33 CFR 151, which is the Code of Federal Regulations, is a federal code, states that we will implement MARPOL regulations. So boom, there we go, tie-in between international and domestic. And you can see we'll further spell out some more items that we want to harp on or be more critical in those areas, or less in some, by stating specifically, well, Annex 1, which is oil pollution, here's your ranges of codes that directly relate to that number or that annex. And we do the same thing for noxious liquid substances and garbage. So we have these other different CFRs that help us govern our domestic policy, which is informed by international policy. So again, looking now at our air pollution or our Annex 6 items, we have this emissions control area. And again, this green line here, and now red, is a 200 nautical mile buffer where we say your exhaust from your engines have to meet certain requirements and standards. So we say this, and we're basically telling companies, hey, don't bring your ships in here if you can't meet these requirements, because we don't need the low-lying ozone or some of the other different chemicals and gases that are produced in the combustion process to land on our population and create respiratory illness. So what are ships having to do? Before they hit that 200 nautical mile line, they have to either switch to another type of fuel, which passes the emissions regulations, or they have to install that SCR that I talked about so that they can actually pacify their exhaust stream and produce chemicals that are less caustic to humans while they're entering that area. And all that's spelled out within the legislation. Now, sulfur. Sulfur is the main driver in this, and if we look here, we have an international trend here. 3.5% is the international standard. Well, we're telling people right now 0.1% is where you need to be to enter port. So this drives really the fuel production. We need low sulfur fuel. It's right now extremely expensive, as well as a maintenance issue because sulfur acts as a lubricant inside our engines. So we have to find workarounds to this, and we have, and we'll continue to develop this technology even further in the future. So if we're starting looking back at ballast water management and how the Coast Guard can actually affect some change here, we can look at these items down here. The Coast Guard needs to develop some penalty scheme for ships that are not following this. They need to create a new national standard, which they have, and we have. They need to find some way to test the ballast water treatment systems and develop a size and an organism standard. Now, currently there is one, but there's some argument about whether it's sufficient or not. Now, the other problem here is because the requirements are so strict, it's very, very difficult to get enough water to sample on a small basis. So what this equates to is we're really giving people something that we want them to adhere to, but we don't have a great way of making sure they're doing it. And that's even true when we get into some of the devices that companies are making to help pacify this water. So if you look here, it's a picture of a typical ballast water pacification system, and we can go to the facilities and watch them operate and be like, oh yes, it's meeting our requirements. Now the problem becomes, I'm going to install this thing on a ship in non-laboratory type environments and now expect the crew to get the same results as in a lab. Not very likely. The other problem too is it's a mechanical system. It breaks down. There's maintenance required. I need to have some sort of inline testing thing to ensure, some sort of testing device to ensure that I am actually getting out the product that I think I am. And right now, like I said before, that's very, very difficult to do. But we're working on the process. So again, back to pollution again and our ships. We've got the VGP, the Vessel General Permit. And basically this is an overall requirement of the Clean Water Act. It's designed to regulate the discharge sources from vessels, and the intent here is to reduce the amount of pollution in U.S. waters. And this covers a lot of different items. It covers deck runoff, ballast water, OWS discharges. We talked about this before, how many parts per million of oil you can actually put back into the water. And I would tell you that deck runoff, you're like, well, why is deck runoff an issue? It's just water that hits your deck and then runs off. Well, there's a lot of different things on decks, the different types of paint that you put on there, different types of pollutants, maybe in environments that you've been in that can now get saturated into the water that's on deck and flow into the water. So it's a big deal. Ballast water, we discussed that. Oily water discharges, again, we discussed that. Hull coatings. Why would hull coatings be something that we want to be regulated and verified via the VGP process? Well, the truth of the matter is that a lot of our hull paints are actually designed to peel off as marine growth gets adhered to them. So as you're going through the water, it increases the friction across these barnacles and microorganisms, and the paint actually dislodges itself from the substrate of the hull and falls off so that we don't have all of these microorganisms slowing down our ship. So we need, and that's called an ablative. An ablative paint peels away as it gets more and more resistance on it. So this is important. What are we putting into the water? Maybe lead, maybe all types of different chemicals. So that's why that's important. Cathodic protection, its main job is to basically protect our ship's hull. So it's going to deteriorate in the water by electrolysis and send itself back into our water column, right? Basically into our oceans. So we need to make sure that we're using chemicals or materials that are not extremely harmful to the environment when we do this. CPP and thruster hydraulic fluid. You might as well just insert any type of hydraulic fluid here because cranes, davits, all of those things, we limit the amount of discharge we can have on those items. The reason this one specifically talks about CPP and thrusters is because they're typically underwater. So you may have some hub leaking on a controllable pitch propeller. The blades move on top of basically O-rings. We could wear those down and get some sort of discharge of that hydraulic fluid into the water, which is bad. We want to limit that. There's regulations about the designs and secondary containment for those items. So you start looking at fire main systems as well, and you see this boat up here that's happily spewing fire main water back into the water. Why do we care about that? Well, the water is being sucked out of the ocean and put right back into the ocean. Well, that's true, but it's also doing a couple of things. If we picked up water inside of our fire main system and it had microorganisms in it, and then we turned off our fire main system, some of that water and microorganisms, they still exist in the water column. So what we're doing now is just basically spewing microorganisms from the last place when we were, or that we operated the system, all over the place. So it kind of ties back into a little bit into our ballast water. But also, as the water is going through our piping systems, it's picking up things like copper, nickel, and magnesium, maybe a little bit of lead, some steel remnants. It's going to be putting some sort of metallics back into the water as well, which is something we need to regulate to make sure those aren't becoming overly abundant in some areas. And then, of course, gray water, which is very similar to sewage. The difference in gray water is that I can typically discharge gray water directly overboard as long as I'm outside of 3 nautical miles. It's not normally contained first, where sewage goes into a containment system and is then discharged when you get into the appropriate area. Gray water, that's not the case all the time. So the problem with this is I can take almost anything and put it down a sink, and that's gray water, and it could go out into the ocean. So I could take a big jug of oil or diesel fuel and put it right into my galley sink, and it would go out into the ocean. And this is why this overall piece here, gray water, is part of the vessel general permitting. So it's important. All this stuff's important because we like our environment and we want to live in it for a while. So there's a lot of different things that are going on. The big thing that we're looking at now is a small vessel general permit. So we've got a lot of boats that fall into that category, a lot of vessels, 120,000 plus. So it's going to be huge, and more specifically for the Coast Guard, this is going to be huge because we now have to regulate all of that and actually make sure that the laws are being abided by. It's no small task. So as we start talking and getting this closer and closer to where we actually operate, which is military vessels, we have different guidelines. We have, as you can see from this quote right here, national defense sometimes may outweigh full compliance with our pollution control measures. And that's important to know, as well as the safety of our ship as a U.S. asset. So we're exempt to a lot of these different rules in federal statutes, but we tend to follow most of them through the Vessel Environmental Manual, which is the one that I discussed earlier in the lecture. This covers everything that we might need, plus a little bit more. So it's got some standards that are elevated over our IMO standards that are federally regulated and required, and some items that are not. So if we look, we see as we move forward, the Vessel Environmental Manual gives us sewage requirements, great, just like the IMO or the MARPOL does. Air emissions, same. Bilge as an oily waste, same. Hazardous waste and materials, same. Solid waste, this is garbage. This is what we're talking about, garbage here. So it's the same. And medical waste, okay, so that was something that typically gets lumped in with garbage in the MARPOL annexes. But in our case, we're saying we're going to be a little bit more strict about this, and we want to regulate how this is because we're in an organization in general. Most organizations have medical waste and normal solid waste disposal plans. This is where the Coast Guard puts their plan into action as a Vessel Environmental Manual. So we've got oil and hazardous substance spills. So we go a little further where we say, yep, we're going to monitor the oil output into the ocean. We're going to also worry about what we do in case of a spill, so our reaction plan. Again, any oil company has to have one of these plans as well. This is where the Coast Guard decided to implement it, was inside the Vessel Environmental Manual. So again, as we move through, we can see we've got the protection of marine wildlife, we've got ship ballast water and anchor sediment. This is all the invasive species stuff here. These are the two items that we're really looking at. And we have another one, noise. Noise. And now this is more along the lines of being a good neighbor. The United States Coast Guard puts vessels into communities, typically into small berths and ports. So we try to minimize the amount of noise that we produce during certain hours, much like if you had a noise ordinance in a local municipality where they said you couldn't play loud music after 10 p.m. that can be heard outside of your property. This is kind of the same thing. So we're trying to be good neighbors, and we want to keep that good relationship with the general public. And then ship and boat washes. Again, this is the deck runoff. This is how are we going to clean our boats and make sure that our soaps or detergents or cleaning agents aren't further polluting the environment in which we are in. So, as we look back, some of the big takeaways here that we want to know is we want to fully understand ballast water management, because that's a huge issue. We want to fully understand all of the MARPOL annexes. We want to understand emission control areas, vessel general permitting, and we want to know what's in the Vessel Environmental Manual. We also need to make sure we understand what our OWS is and what it does, what its overall purpose is, as well as what type of substances can be produced by our ship, whether that is sewage, whether that's the engine emissions. All of those different things are important to our adherence with federal and international law when it comes to environmental stewardship. All right. I hope you have a good day.